If you're watching this video, you more than likely are running your own Minecraft server, and you've thought to yourself, I kind of know what Docker is and what a Docker container is, and I want to create my own Minecraft container image. So if that is the reason you're watching this video, welcome. In this video, I'm going to show you two different ways to create your own Minecraft server container image. The first way I'm going to show you how to use an existing Minecraft server container image to build off of and create your own. Maybe you're already using one like the ITZG Minecraft server container image, and you just want to modify it a little, make it your own. And then the second option I'm going to show you is creating a Minecraft server container image from scratch using a vanilla plain OS. So if you're not familiar with what Docker is or what a container image is, I actually have a YouTube series called Running Minecraft in Production, and the first video is labeled How to Run Minecraft on Docker. In that video, I go really far in depth on how to install Docker and Docker Desktop on Windows, and also what Docker is and what a container is. So if you're curious, go ahead and check that out. But if you already know, continue watching. The majority of this video is going to be done using the Docker CLI, but where possible, I will use Docker Desktop and Docker CLI so you get the best of both worlds. So like I said in the beginning of the video, I'm not going to show you how to install Docker, but I do have a YouTube video called Running Minecraft on Docker that goes over that in depth. In the spirit of keeping this video beginner friendly, where possible, I will use Docker Desktop, but a lot of these things that we're doing, building a container image, we need to use Docker CLI. So the first thing we actually need to do is we need to pick a place on our computer that we're going to work out of. So I have created a folder on my PC called Minecraft, and that's going to be where I'm going to work from. And then I'm going to open up Visual Studio Code. If you're not using Visual Studio Code, I highly recommend you go ahead and download it. It is a great tool when you're working with any kind of code, whether that be just programming. It is a great tool for any of the kind of stuff that we are doing. And then I'm going to go over here to the Explorer icon, and I'm going to hit Open Folder. And I'm going to navigate to that folder that I had created where I want to work from, and I'm going to select that folder. And now you can see here on the left-hand side, I've got that Minecraft folder open. And so that's where we're going to work from for the rest of this video. So the first example we're going to go over is creating your Minecraft server container image from another Minecraft server container image. So to get started, I'm going to create a new folder, and I want to call it existing container. And then because I'm going to have multiple scenarios here, I want to keep the files separate. And then I'm going to create a new file. And I'm just going to call this Dockerfile with a capital D. And you'll see here in VS Code that the little Docker symbol has actually appeared next to my file. And that is because I have installed the Docker extension. So if you're using Visual Studio Code and you go to the extensions icon here and you search for Docker, you'll see the Docker extension that you can install, and it helps you with formatting. So the Docker file is the file that contains the script or the code or the instructions on how to build a Docker image. If we think about Docker containers, first comes the Docker file, then comes the Docker image, and then comes the Docker container. So we write a Docker file, how to build an image, we build an image, and then we use the image to run a container. 99% of the time you are creating your own Docker images, you are going to specify the first command in your Docker file as from. And this is telling Docker what base image do you want to use, existing container image, to build off of. We're essentially copy and pastaing another image and then adding our own sauce on top. So because this first example is showing you how to create your own Minecraft server container image from an existing one, that's what we're going to use as our base image, an existing Minecraft container. So if we go to hub.docker.com, right, there's a fairly popular Minecraft server container image that a lot of people use called ITZG. And it's pretty heavily customized with a lot of different options. So in this example, maybe you're using this container image or another container image, and you're not necessarily happy with everything that's going into it, or maybe you want to make some changes, you want extra things to happen on startup, or you want to add some extra files to the container image. Well, that is what this scenario is for, and that's when you would create a container from another existing Minecraft container image. So let's go ahead and do that. So we're going to copy the name of this container image, And we're going to use that as our from. So now we're telling Docker, when I build this image, start from the ITZG Minecraft server container image and then build on top of it. The next step is we have to start adding our files to our Docker image. Any scripts we might want to run when the container starts. So to do that, we specify what's called working directory or workdir, and then we provide a path. And this would be a path within a container. So if I provide /app, then other Docker commands like copy or run will happen as if they were in this directory. They'll be executed from this directory. A lot of people like to say this is the equivalent of cding or changing directory into this directory when Docker runs the commands to build the image. So for this example, the files that I want to copy in to this Minecraft server container image are a whitelist, right? I have a whitelist already on my Minecraft server, and I just want to add that to the container image so it's there every time it starts. So I'm going to put my whitelist here. So now what we want to do is we want to provide the copy command. And copy has two options, source and destination, that we can provide. So the source is going to be relative to this Docker file. Let me just put that in there. Whitelist.json. And then where in the container would you like to put whitelist.json? Well, if you're familiar with the ITZG container, there is a documentation link here on their Docker Hub page. And when you go there, they have a data directory documentation section. And all of the Minecraft data gets put into the /data directory in this container. And it just so happens that whitelist.json also gets read from /data. So the destination inside of the container that we would like to put whitelist.json is going to be /data. And then maybe I've got a script I want to run, right? So I'll do like build info.shell. And this will be a bash script that I want to run every time my container starts. And maybe we're just going to echo some information into a text file. So every time the container starts, we're going to go ahead and we're going to create buildinfo.txt. And it's just going to have this information built by the sudo inside of the file. So then we want to copy that in as well. So we're saying buildinfo.shell. And we want to put that somewhere on the computer, maybe /opt. So then we come to the run command, and we can pass in a command. So run is going to execute a command on top of the current image. So if we look at what we've done so far, we are going to build an image using ITZG Minecraft server as the base. We are going to change into the directory app inside of the container as we build it. We're going to copy whitelist.json from our working directory over here into /data on the container. And we're going to copy buildinfo.shell over here from our working directory into /opt in the container. Now, because we've specified a working directory, anything we run is going to run from within this directory in the container /app. So anything we provide here, if it has a path, it needs to be relative to /app within the container. And run is normally used for installing dependency or running build steps, anything that's needed during the build process. You wouldn't use this to execute, say, a script that you needed to execute every time the container started. This would be something you needed only during the container build process. So for us, right, we're going to install JQ because the base image doesn't have JQ installed by default. And if you're not familiar with JQ, it allows us to parse JSON. And then we're also going to execute buildinfo.shell. So again, we're only doing these when we build the container image, not when we run the container image. And then we're going to provide expose and a port number. Now this is telling the container image when the container starts, what port are we going to listen on for incoming connections. So by default, Minecraft is 25565. Now we're going to stop there, and that's all we're going to put in this Docker file because we're using an existing Minecraft server container image to build from. So we don't need to provide anything extra, such as how to download Minecraft into the container or how to start the Minecraft server, because that's already happening because we're already using a Minecraft server container. All we're doing is adding some extra files and downloading some extra software into the container to make our lives a little easier. Now, if you wanted to, right, and we'll see this in the next example where we create one from scratch, you could provide cmd and then an executable to run, right? So this would be a command that runs every time your container starts, but it could be overridden by a user. Or we could provide entry point. So we don't need those two right now. We will use those when we build our own Minecraft server container image from scratch in the next example. But for now, this is all we should need. So with our Dockerfile built, we're ready to start executing the docker build command to then go ahead and build it. So what I did just there in Visual Studio Code is I went up to the top to terminal and I hit new terminal. You could certainly run this through PowerShell or command prompt or whatever you choose, whatever flavor of terminal you're comfortable with. So from this working directory, Minecraft, right, I'm going to go into existing container. I'm just going to do a docker ps, and there are no containers running. I'm going to do a docker image ls to list the images on my machine. Currently, there are none. So to build the container image from a Dockerfile, we use the docker build command. And we're going to want to pass the flag -t. And this allows us to name, or tag is what -t stands for, our container image. And so I'm going to call it custom-mc, short for Minecraft. And I'm going to add colon, and this part's optional, and a version number. So maybe this is version 0.1 of my container image. And then I'm going to specify where my Docker file exists. And because I am running Docker build from within this existing container directory, which is my working directory, I'm just going to specify here with a dot. And so now Docker is building my Docker container. So we can see it says building from docker.io, itzg, Minecraft server. And then it changes directory. Oh, I had a typo in my shell script here. Let me run that again. All right, and it has finished. So I'll clear the screen. And now when I run a docker image ls to list the images on my machine, I have an image called custom-mc, and it is version or tag 0.1. So I should now be able to run this image. So if I go to images in Docker desktop, we'll start with Docker desktop and then I'll show you Docker CLI. I can see my image is here, right? And I can hit the play button or the run button. And what do I want my container to be named when it starts? We'll just say Minecraft. We're going to do 25565 for the port. And we haven't covered volumes yet, but environment variables, we need to provide EULA and the value of true. And this is a requirement for Minecraft to start. And the only reason we can use these environment variables is because we built our container image from the itzg Minecraft server container image, which has these environment variables already pre-configured for us to set. And you can see that in the documentation for the itzg Minecraft container if you go to the variables section of the documentation and you look for the EULA variable must be set to true. So we'll go ahead and we'll run that and Minecraft should start up for us. So the equivalent Docker CLI command to run this container would be docker run and then our arguments. So we're going to do -p for port. So we're going to map the port on our system to that port we exposed to 5565. We're going to do -e to pass in that EULA equals true environment variable. We're going to do -d so that our container runs in the background and doesn't run in the foreground and take over our terminal session here. And then we're just going to pass the name of our container image that we created. And I'm doing this after the fact. I'm recording this after the fact, but it's named existing Minecraft for me. And then we'll do docker run. And then we can do docker ps and we can see existing Minecraft running. And it should start up the same way you see in Docker desktop. So Minecraft should be up right now, but before we attempt to connect, let's make sure that the things we added to the itzg container image to create our own image actually took effect. So the first thing I want to look for is I want to make sure JQ got installed and that the buildinfo.shell script got copied over and run successfully. And if we look at that, it should have created a file in /opt called buildinfo.txt. So over here in the Minecraft container, let's go to files and let's go to /opt. And we can see that we do indeed have the buildinfo.shell script and buildinfo.txt. So if we go to the terminal and we go into /opt, and we do see our files there, we can inspect buildinfo.txt, and we can see that our script did indeed run successfully. And then the other thing we're looking for is that whitelist.json file that we put on here. So that would go into /data. And we do see whitelist.json, and if we open it up, we do see our whitelist the way we expect it to be. So we have successfully used an existing Minecraft server container image and then added a few different seasonings, as you will, on top of the main recipe. So let's go ahead and let's test our connection. Let's attempt to connect and log into Minecraft. So we can see that the ITZG container is actually using 1.20.3 version of the Minecraft server. So on my Minecraft client, I just want to make sure that I'm also using 1.20.3, and I'm going to hit play. I'm going to go to multiplayer. And I've got a server here called custom, and because Minecraft is running on my local computer, I can just specify localhost and then the port that the container should be exposed and listening on to 5565. So I'm going to connect, and we can see down here I have successfully logged in to my Minecraft container image. And as we can see at the bottom of the log, I have successfully connected and logged into my Minecraft container. All right, it's time to cover the reason you're probably watching this video, how to create my own container image of my Minecraft server from scratch, meaning unlike the existing container example that we just went over, we're not creating from an existing container image that contains the code to run a Minecraft server. Instead, we are going to, I'm just going to create a new folder here, right? And I'm going to call it from scratch, right? So this is my working directory, and this is where I'm going to create the Dockerfile for creating my Minecraft server container image. So just like we did for the existing container, right in here, we're going to create a Dockerfile, capital D, and that's it. No extension. And then we're going to define our first command for our Docker build, and that is going to be from, and we're going to choose our base image. So unlike the existing container, let me just pull these up side by side. Right, so this is the container image we built earlier. Unlike that one where we use an existing Minecraft server container image, we are going to just use a vanilla operating system container image. So we're going to use Ubuntu. And you can see that it's kind of finishing it for me. And that's because I have the Docker extension installed in VS Code. So what happens is I can actually, because I have this extension installed, I can click on this. And it's actually going to bring me to Docker Hub, the page for this container image. And on here, you know, we can look at the supported tags. We can look at which are versions of the container image, right? So there's latest, there's different tags, and there's different architectures. And this is important. You never want to try and create a Windows container and run it on Linux, and vice versa. It's just not going to work. And then I'm going to specify the tag or the version of this Ubuntu container image that I want to build from. And I'm going to do 22.04. Now hold up real quick. I just told you that you cannot run a Linux container on Windows. I'm running Docker Desktop on Windows. How am I running a container built from a Linux image on Windows? Well, you see, when you install Docker Desktop on Windows, it actually runs in an emulated Linux environment. So it runs Linux containers. If you were to install Docker Desktop on Windows and try to run a Windows container, it would yell at you and tell you, please configure Docker to run Windows containers, to which this day I have never successfully been able to configure that. Your mileage may vary. Enough of a tangent, back to our build here. So we're going to build our container image from a base vanilla blank Ubuntu operating system image. And then we're going to provide a new Docker command that you didn't see earlier in the first example, and that is env, and this stands for environment variable. So we want to set an environment variable inside of our container when it starts. So we're going to set an environment variable called Debian frontend, and we're going to set the value to non-interactive. Now we do this because Ubuntu, when we do certain things like install packages or install other software, sometimes it has a tendency to ask the user for a prompt. If we're doing a Docker build, we cannot respond to that prompt manually. So we set this environment variable in Debian-based operating systems so that we are not prompted for those things. So this has nothing specifically to do with Minecraft, but it helps keep our Docker builds healthy as we build them. So then next we're going to specify working directory, and I'm going to call it Minecraft. Now this doesn't have to exist anywhere. All this does is tell Docker build, when we run the Docker build command, it tells Docker create a /Minecraft directory, cd into it, and then run all of our commands from that directory. So at the end, we will get a container image with a /Minecraft folder in it, or directory. So next we're going to specify run. What commands do we want to run when we build the image, not run the container? So it's important to remember run is for building the image, things you want to happen only when you build. And then there are other commands that we use to perform actions and run commands when we start the container from the image. So keep that in mind. There's a difference there. So what we're going to do is we're going to install some software, right? Because this is a base vanilla image, it doesn't have all the software required to run a Minecraft server. So we're going to use the package manager apt or apt to update and install OpenJDK 17, which is required, wget, which we're going to use to retrieve files from the internet when we do our build, and then we're also going to remove a bunch of files and directories that make our container a lot larger than it needs to be. So we're pruning unnecessary things to make our container smaller. Then we're going to do another run, and we're going to provide another command. And the command we're going to run is the command to actually retrieve our Minecraft server.jar file. So we're going to run wget, which we just installed, and we're going to call it server.jar when it gets downloaded. And it's going to be downloaded into the /Minecraft folder because that is where we are running wget from when we do a Docker build. Now this link here, who pooped? Who pooped? Now this link here, where did I get this from? Good question. So if you just Google download Minecraft server, right, you'll be brought to this page where they have a link to the latest version of the Minecraft server.jar. So that's where I got this link. So if I actually just copy this link address, right, I can go ahead and paste that in there. And now I'm going to get version 1.20.3 of Minecraft when I build my container. So unlike the itzg container where we are downloading the Minecraft server.jar every time the container runs, we are downloading the Minecraft server.jar when we build the container so that we do not have to download it every time we run it. It's already downloaded. Then we're going to run another run command. And if you're familiar with Minecraft, you will know that you cannot start a Minecraft server unless you accept the EULA. So we're going to do echo, and we're going to say EULA equals true into a file called eula.txt. So what's going to happen is inside the Minecraft folder, the Minecraft working directory in the container, we're going to end up with eula.txt, and that is going to contain this text, EULA equals true. And then when we go to start the server, Minecraft will see this file, read it, see that this is true, and allow us to start the server. Next, we're going to define expose and then the port number that the Minecraft server is going to listen on. So our container will also listen on this port for traffic. So when we connect to the server, we're going to connect on this port. So by default, this is 25565. So that's what we're going to set. Now the next two commands that we're going to specify for our Docker file to run when we build a container are cmd and then some kind of action to take, and entry point and some kind of action to take. Now you don't have to use both of these. You can just use cmd
or you can just use entry point. But the difference between run and CMD and entry point is that run is executed when you build a container image. So I, as the owner of a container image, I build it and I push it out somewhere to Docker Hub so that people can consume it. When I build it, I'm including server.jar in the image. And then when you consume my container image and you run it, that is when CMD and entry point commands are run, when the container starts. Now, it's good practice to normally combine both CMD and entry point and use them together, but you don't have to. You can just specify one or the other. Now, the difference between CMD and entry point is that normally the entry point, maybe it would make more sense if I put these in the order that I'm about to explain them in. So entry point is normally the process to be executed inside of the container. So that would be Minecraft. And then CMD is normally the default set of arguments that will be supplied to the entry point process. Right? So if you're familiar with how we execute Minecraft, we run Java and then we pass in some commands like maybe server.jar, right? So Java would be the entry point, and then all of those extra arguments would be under CMD. So let's see what that looks like. So if we pretended we didn't really want to use entry point, right? The command we're going to use to start our Minecraft server when the container starts is Java, and then these 1, 2, 3, 4, 5 arguments, right? We're going to specify our memory usage, -jar, server.jar, Noe GUI, right? These are all arguments being passed to the Java process. So we could build this container and run it just like this, and that's fine. But if we wanted to make this more flexible, we could take Java and move that under entry point. So then Java will run, and then these arguments will be provided to Java. Now this provides maximum flexibility because people who use our container, if they don't provide any arguments, then Java and then all of these arguments will be run by default. This is the default command. But they can also specify their own arguments to the Java process and override these if they so choose, if they need to add additional things onto this command. So if I open up a terminal, so to help get this point across, let's say I build my container just like this. Then when I run my container, let's say the image is called Minecraft and it's the latest. What would happen is the container would start and it would just run Java and nothing else. So then when I run this container, would have to specify the arguments like -jar, server.jar, right? So not really that efficient, but it gives me some flexibility. I can pass in whatever commands I want. But if I commented out this, when the container starts, it's not going to run Java, but it's going to run this, and nothing's really going to happen. Now, if I have both of them, I get the best of both worlds. So I build the container, right? What's going to happen is when the container starts, it's going to run Java and then pass in all of these arguments to the Java process. But what I can also do is I can override this. So say I have my container image built and I do docker run Minecraft latest. I can specify these arguments, right? -jar, but I can override them. So maybe I want to do -xmx and specify 2048M instead of the default 1024M, right? So that is the flexibility we get when we use entry point and CMD together. So enough of my rambling. Let's go ahead and actually build this Docker container now and test it out. So what we're going to do is making sure that we are in the same folder or directory that our Dockerfile is in. We're going to go ahead and run our docker build -t, and we're going to specify the name of our container image. So this will be Minecraft custom. Let's do that. And we can also specify a tag. I'll do latest. And then period dot, just meaning this folder or directory that we're currently in. So we're building the container image. So the container image is built. So now if we do a Docker image ls, there we go. We can see that we have our custom image name here and our tag is latest because that's what we set the tag to. So then over here on Docker desktop, if we're using Docker desktop, if we go to images, we'll also see our image there, and we can hit this run button and we can specify the name of the container as we'll see it when it's running. So we'll just call it Minecraft and 25565, and we don't need to do anything else. And so we're going to run our container. And now when it runs, it's executing the command that we specified to actually start the Minecraft server. And if we go into our files here, we should be able to see we have a Minecraft folder. That's the working directory we set when we built the container. And we have our eula.txt with our eula equals true as we expect to see it because we had created that file when we built the container. So we're not putting that responsibility on the users that consume our container image to accept the EULA. We're just doing it for them when we ship the container. So now under containers, I can see my Minecraft container is running. So I'm going to load up the Minecraft client, and we can see that we're using version 1.20.3 of Minecraft server. So I'm going to load up the client here so I can test the connection, and I need to make sure I'm on the same version as my server, which it's not on this list. So I'm going to go to installations and new installation, and I'm going to make sure I do 1.20.3, create that, and then I will go ahead and choose that, hit play, multiplayer, and we want to go ahead and make sure. So we're connecting on localhost 25565. We can see that we should be able to join here, and bam, we are connected to our Minecraft container. So the equivalent Docker CLI command to run this container image, if you're not using Docker desktop, right? So I just did a Docker image ls so I can get the name of the container image that I want to use. Is going to be Docker run, and then any arguments, right? So we're going to do -p, and this is going to map the port on my PC to the listening port configured that we've exposed for the container. So I'm just going to go 25565. I'm also going to do -d so the container starts in the background. I don't want it to, take up my terminal. I want to be able to keep using this terminal. And then the name of the container image, so Minecraft-custom latest. And that is all we need to do. And then if I do a Docker PS, my Minecraft container is running, and we can see that the command that it's executing. And so that's a Docker CLI command. So that's it for this video. There are other Dockerfile instructions, as you can see, that we did not go over just due to time. If you are interested in these, I'll leave a link in the description so you can go ahead and check some of these out. There's some other cool ones in here, and you can continue learning. I'll also have a link in the description to a GitHub repository that has the Docker files as we built them in this video, so you can copy and paste them or use them as a reference.